Hey guys, this is number 27 that you requested I do from the homework assignment. The algebra and it gets a little intense, so we'll go through it nice and slow. I'm going to give you two approaches to it. Also, what I think I want to do with this one is I'm going to start off by taking a graphical approach to it, because I think a lot of times when we're going through all of these rules with our chain rule and our product rule and our quotient rule, and then we get all hung up in all the algebra that falls out from those, we kind of lose track of the bigger picture of what we're really finding. So I'm going to, before I go through it, take you to the graphing calculator. And we're going to go enter this function, see what it looks like. We're going to take the derivative at a specific point so we can see what that is. Then we'll go take an algebraic approach. So my function for this one is x divided by the square root. And it's the square root of, and don't forget your parentheses, x squared plus, and I'm sorry, I've got to go kind of slow on this graphing calculator because it doesn't keep up with me. So there's my function, and I'm going to go hit graph, and I'm also going to go give a large screen view for this. So here's my function, and it doesn't even really matter that you can't see the entire thing. So it's creeping along right here. We got a little bump going on there by 0. And remember that when we're finding the derivative, whether we're doing it algebraically or graphically or in a real world context where it's a rate of change, we're finding the slope of the tangent line at a point. And when we do the derivative of a function, we get an equation for the slope of the tangent line at an x value. So I'm going to go calculate the slope of the tangent line at, let's say, at x equals 2. And I'm going to go get a numerical value for that. So I'm going to go to my graphing calculator and make it calculate the slope of the tangent line. So remember, that's under second calc. And I'm going to go down to my dy dx option number 6, which is my derivative option. And down on the bottom here, it's waiting for me to tell it, well, where do you want me to take the derivative? And I'm just, for demonstration purposes, going to do that at 2. I'm going to write down my answer so we remember it later. And so kind of, you might need to write this down so we remember. We're at about 0.089. So what that's saying is, at 2, when I do the slope of the tangent line, it's about 0.089. That's a graphical approach, and it was very quick. What we're supposed to do with number 27, so I'm going to go back to your notes, is we're supposed to come up with a function that'll give us that slope. So when you first look at that, we've been talking about, well, what do you see when you look at that? And you guys, I think, told me already with number 7 that you see quotient rule and you see chain rule, which is exactly what's going to be in this one. So we need to go organize ourselves because we've got a quotient rule going on. So remember our quotient rule, our phrase is low d high minus high d low, draw a line and square below. So we need to do our lower function, which I think I'll just call it low for now, which is x squared plus 1. And remember, for derivative purposes, it's easiest if you write that as a power. So our square root is to the half power. That's my low function. My high function, I'm just going to write it like this, is x. We also need the derivative of the lower function, and this is where you've got to be a little careful because this is where our chain rule comes into play. We're going to use our power rule, and we say, well, it's 1/2 of x squared plus 1 to the negative 1/2. Knock it down a degree. You guys have been very good about that. This is where you have to be careful because remember, this is a chain rule. So in here I have another function which I need to take the derivative of. And we've been working with that a lot. So I have to multiply that by twice x. I'm now going to clean that up so it's a little more user-friendly. So these are going to cancel. I'm going to get x times x squared plus 1 to the negative 1/2 power. That's the derivative of my lower function. The derivative of the higher function, way easier. That's just a nice 1. So all of this organization, I would suggest you keep this all off to the side. And now let's go in and apply our quotient rule. The quotient rule says to get the derivative, which we call y prime, or we've been interchangeably calling it dy dx also. The quotient rule says you do low, so I forgot my derivative there, you do low d high, so I'm going to have x squared plus 1 to the 1/2 power times the derivative of the higher function, which is just 1, which won't change it. It's low d high minus high d low. And when I multiply those, I'm going to get x squared times x squared plus 1 to the negative 1/2. So again, back to our quotient rule, low d high minus high d low, draw a line, and square below. And when I square my square root function, they undo each other. So I'm going to end up with an x squared plus 1 on the bottom. This is where you can take two approaches to this problem. So what I'm going to do is take both, because I think you guys have been going about 50-50, and I want you to use what you're most comfortable with. So I'm going to split my paper here, and I'm going to take both approaches. I'm going to first take the books approach, and what you would see if you logged on to CalcChat to do this one. What you would see is they're going to take this top and they're going to factor it. And the reason this method is a little tricky is it's hard to see how to factor when we're dealing with fractional exponents and negative exponents. So I got to take you back a little bit to something you already know how to do. I'll do it maybe up on the top, or maybe down in this bottom left corner. You guys know that when you have x squared plus x to the 5th, that you factor out that lower power. And then when you're trying to decide what the power is that's left, well, you say there's x to the 3rd. And you also know that when you multiply that back in, you better get x squared plus x to the 5th back. Well, that's exactly what we're going to do. We're just going to do a kind of algebra on steroids here. And we're going to factor that. We're going to factor the lower power out. Well, that's the negative 1/2 power. So we're going to say I'm going to take out x squared plus 1 to the negative 1/2 power. That's what's in both of them. And then we've been using square brackets for what remains inside the parentheses. And this is where it gets tricky, trying to decide what to put back in so that when I distribute, I get x squared plus 1 to the 1/2. Well, you remember your rule from Algebra 1 that when you multiply and the bases are the same and you add the exponents, you could easily see, well, that's to the first. Get negative 1/2 plus 1 is a positive 1/2. And there's your x squared plus 1 to the positive 1/2. And then I need to have my minus. And I also need to get that x squared back. And keep in mind what was down below. So again, I'm going to repeat that because that's where things get a little tricky. Again, the calculus is easy. It's this algebra that's a hard thing. So I decided to factor out a negative 1/2 power because it was the smallest. And so when I pull it out, remember I have to put back in what I need to get it out back. So on my first multiplication, this first arrow coming in here, I'd have x squared plus 1 as my base to the negative 1/2 plus 1, which is x squared plus 1 to the 1/2. That's what I need. When I bring it into the second term, okay, I'd have x squared, check, times x squared plus 1 to the negative 1/2, check. So it looks good. Now, I clean up what's in my inner parentheses here. I have x squared plus 1 minus x squared. So my x squareds go, right? So on the inside parentheses, I actually just end up with a 1 in there. So I'm going to have x squared plus 1 to the negative 1/2 on the outside that I pulled out. And then on the inside, I'm left with just a 1. So I'm not going to write that down because you guys can't, so I'm left with just a 1. So that is all over x squared plus 1. But then remember, we never leave negative exponents. They get sent down to the basement to be more positive. So when I clean this up, I'm going to get 1 over x squared plus 1 times x squared plus 1 to the 1/2, which is 1 over, and again another algebra rule, x squared plus 1 to the 3/2. And that's my final answer taking that route, and that's the route that CalcChat will take you on. However, I'm going to take you on another route because I think that whole factoring with the negative exponents, I think that can cause some big problems. So I'm going to go back to the original problem here. I think I'm going to clean this up a little so you can see it. On the bottom I had an x squared plus 1. All right, and what I'm going to do is I'm going to take this and put it in radical form, and then I'm going to clean it up. So watch what I'm going to do. We know that the 1/2 power is square root, so I'm going to write this first one as the square root of x squared plus 1. I'm going to write the second one as x squared over, because it's to the negative 1/2, the square root of x squared plus 1. And I know that that's my new denominator there. And I'm all over x squared plus 1, which at first glance looks messier. But remember our cleanup process for these. When we clean this up, we multiply. And when we do that, the roots go. So I end up with x squared plus 1, multiply, minus x squared, all over the square root of x squared plus 1. Okay, so I just cleaned up that top. And this is the row that I think is a lot cleaner for you. And then on the bottom, I've got my square root of x squared plus 1, and then it's still all over x squared plus 1. Oh, watch the cleanup of it. I end up with 1 over, and then again on that bottom, I've got x squared plus 1 to the 1/2 times x squared plus 1 to the first. I get the exact same answer. I think it's just a little cleaner. Now again, this is the function that gives me the derivative at any point on the curve of my graph. So I'm going to remind you of what I did back on the graphing calculator. I'm going to bring it back up here. When I originally started, I went to my y equals button and I entered the original function, and it gave me this graph over here that went like this. And I went graphically to 2, and I used my dy dx option, and I got a point 0.89. So what that means is if I did this correctly and all my algebra is sound and solid, when I put a 2 in for x, which would give me 1 over 2 squared plus 1, which is 5, to the 3/2, I better get 0.089. I'm going to go check it on my calculator. Let's go take a peek. So I'm going to get some clean paper here, and I'm going to clear that out. And I'm going to do exactly that. I'm going to do 1 divided by 5 to the 3/2. I'm going to see if my algebra took me soundly. Bam! Love it! It's exactly what we got graphically. So that was by far the hardest one in there. Before I leave you for this assignment, I think you guys were doing a really good job on all the other ones. The only one I'd like to caution you about is number 51. You're going to work through that. You're going to do the product rule. You're going to get a really good sound answer. You're going to open it up to the back of the book, and you're going to go, what? Mine doesn't look anything like this. And the reason it doesn't is because they're going to use a trig identity to clean it up. So you should have that yellow sheet of trig identities that I gave you, and you should take that out, and you should find a trig identity that'll help you clean it up, and then you will answer that question instantaneously. And you might, some people, I've had a couple people say, how am I supposed to remember all those trig identities? You don't need to. If there's one on the AP exam that you're expected to use, they'll write. They'll say recall, and they'll say recall that sine squared theta plus, and they'll tell you what the trig identity is. So you don't need to memorize them. You need to go to your yellow sheet and you need to find it. Other than that, we were very successful today, and you guys have a great weekend.